Design Part 3. Now in this lecture we will study about scalar and vector. So what is scalar and vector? This is my first question. What is scalar? So scalar is the physical quantities which have only magnitude and no having direction. So in this quantity we only care about magnitude. We don't care about direction, whether it is in x direction, whether it is in north and west, whether it is in south direction. This doesn't make any sense for scalar quantity. For example, if we take a number 4, if you rotate it, it is still a number 4. It is rotated. It never gives any changes when you take different direction for it. So all the numbers are scalar quantities. Like area is also a scalar quantity. If you turn it here, the paper, I turn it vertically, then its area is same as I keep it here. Its area is same in this case also. These are all a scalar quantity which have only magnitude and does not possess any direction. But we will study that some scalars have also direction but cannot be regarded as scalar quantities, which we will deal in the vector when we study in vector. So the example, some of example is area, any number, volume, pressure, energy, work, time, length, distance, speed, density, and so on. These are the scalar quantities. So those quantities which have only magnitude and keeping change is its direction, does not change its value, then it is called a scalar physical quantities. Now what is vector quantities? So here vector word means possess some particular orientation or direction. So this is called vector quantities. Means a physical quantity must be measured, so it has some magnitude always. Whether it is scalar, whether it is vector, it has magnitude. So magnitude is the necessary for any physical quantities. But when a physical quantity have direction also, then we say it is vector quantity. So those physical quantity is in loose sense. Those physical quantities which have direction as well as magnitude, then they are called vector physical quantities. But it is in a loose sense. In mathematical and concrete sense, we can say those physical quantity which have magnitudes or direction, as well as which must follow vector addition rule. Vector addition rule is the necessary condition for the vector quantities. Those physical quantities which follow vector addition rule, you can say these quantities are vector quantities. So what is the difference between a scalar and vector? First of all, I give you some example for the vector quantities. Here velocity is the vector quantities. Why velocity is the vector quantities? Because when we say Mohan walks along a road in the east direction with 20 meters per second, then this 20 meters per second towards east, or can say 20 meters per second east, or you can say plus 20 meters per second if you regard east as positive. That's why here you can say this plus indicates direction, this east indicates direction, this arrow also indicates the same direction. So it has magnitude. Magnitude means it can be measured. Here magnitude is 20 and meter per second is the unit by which it is measured, and the direction is this. So velocity is the vector quantities. But sometimes some quantity has direction and magnitude, but it cannot be regarded as vector quantities. For those, we have to go for vector addition rule. When it follows vector addition rule, it is confirmed that it is velocity. So in the loose sense, I have give you a demonstration that when a vector quantity possesses direction as well as magnitude, it is a vector quantity. Now, what do you mean by direction in mathematics or science? First of all, for general, we assign the north direction or upward direction as positive or downward direction as negative. Similarly, we can say that in the right side we can take it as positive, and the left in we can take it as negative. So a same value can be negative if you go in the left direction, and if you go in the right direction, its value becomes change. For example, if you go 2 meters in the right side, it is 2 meters. But a man goes 2 meters in the left side. How can it convey both the cases? Is it same? Is it same in magnitude? It is same in direction? Or both the quantities are same? It is a scalar quantity or not? These are the questions. Here you can see here, if you go 2 meters in the right direction, how can you express it? We can express it as, we can say it is east, we can say it this arrow, we can say plus, and same you can say for this is minus or west or arrow this. Have you got my point? This is the method to express the direction also. This is the complete description of a physical quantity of your information. If you say only 20 meters per second I go, how can we know that where you go, in which direction you go? So this is the mathematical expression, mathematical symbol that we can use it for direction. Okay, so for the direction we can use this chart as this is positive upward, this is negative, and this is positive eastward, and this is negative. So if you have to reach at this point, you can say you have to go towards east, let's say 2 meters, and now you have to go upward, let's say 3 meters. Then we got the, if you go directly, we got the same point. So there are many ways to go there, go the same point. So we can say here I travel plus 2 meters and I travel it plus 3 meters. We have to mention something because it is in eastward, it is in northward, but here is plus. So here you also want to mention some angle for the complete descriptions, because here also plus 2 means maybe east, maybe north, but where exactly it is. So how can you express? So we need some another method to express all the details. We have angle. And how can we measure angle? By some reference line. We have to measure angle from this x-axis. No, do you get my point? We have to measure, generally we have to measure all those angles with this line. So if anybody is moving along this line, it means it covers 0 degree, yes or not? If it goes upwardly, then it makes an angle 90 degree. So these are the methods to express the direction of a physical quantities. Have you got my point or not, my dear learner? So direction can be expressed by sign, and direction can be expressed by angle, and direction must be expressed by a Cartesian coordinate system, that is x axis, x dash axis, y dash axis. Have you got my point? We will deal in greater detail about the vector quantity. Now So the examples of vector quantities are acceleration, acceleration is denoted by A, velocity denoted by symbol this, momentum. We will deal about all those vector quantities ahead, but here I only mention the name. You can observe also the notation. You have to remember the notation. Momentum is denoted by small p, force denoted by capital F. And you must remember all the vector quantity which is given by notation, it also seems as a scalar. So scientists also give us different symbol for it. We have to take an arrow above it. Another also, it can be denoted by dark or bold letter somewhere, but here we use only this symbol, a letter, and on its head there is an arrow. Arrow indicates the direction and letter indicates the name or the symbol. That is, it is a vector quantity. So you can read it as A vector, B vector, P vector, F vector. Have you got my point? So force, impulse, that may be J vector or I vector, and various kind of vector quantities, electric field, E vector, and so on. Okay, these are the examples of vector quantities. So what is the difference between vector quantities? So a scalar quantities needs a magnitude or value. Also a vector quantity also need a magnitude, because those are physical quantity, and physical quantity must have some quantitative aspect, means must have some value that can be measured. Okay, so this is the similarity between two, vector and a scalar, and the differences are scalar have no direction. You can see work is a scalar quantity, or energy is a scalar quantity which have no direction. Power is a scalar quantity which have no direction. If I say an object has 2 joule energy, in which direction it has 2 joule energy? It is a meaningless statement. Okay, so work and energy is a scalar quantities. But force is a vector quantity. Why? Because if I push a body, its effect in a particular direction. If I push a body in east direction, it goes in east direction. If I push a body in north direction, it goes in north direction only. Have you got my point? So this is a vector quantity, and so it must have direction. This is the difference. And now scalar never follow vector addition rule, but it can follow algebraic addition rule. You have known about algebra. How can you add two terms? For example, x plus x equal to 2x, 3 plus 2 equal to 5. These are the algebraic addition rule. No mentioning about direction. You just take it value and collect it and then give your answer. For example, if I want to add 3 plus 2, so you take 3 unit and then you take it 2 unit after that and count it. It becomes 3 to 5 becomes 5. Have you got my point? But in the vector quantity it is meaningless. In vector quantities, if direction will change, the value may or may not be changed. So it depends on direction also. If I have a 20 meter per second value, in different direction it may have lesser value. In different direction it may have another different values. It depends on direction. We will study about how after changing direction how the value changes. We will study. But now here you can see the it follow algebraic addition rule. Algebraic means simple addition rules. Algebraic addition rule. But it follow vector addition rule. Vector addition rule. Now the next point is scalar never be negative. It is an interesting point. You have known about the number can be negative, can be positive, yes or not? -2 is also a number and 2 is also a number. And I have already said that number is a scalar quantity. But I have written here that it is never be negative. What is the meaning? Actually, -2 has direction. In the previous class, you have studied, take it as a number. But now your mind becomes broad. You have known various things. Now you think about what do you mean by minus? If you take it left to the 0, you assign a value minus. If you take it after the 0 or right side of 0, you assign a positive. Have you got my point? Means here you deal with direction. But in the previous classes, you don't care about it because it is a higher concept. So here you have studied about what is the direction. How can you express? Actually, minus sign indicates the direction here. Direction 2 meter you have traveled in westward direction, 2 meter you have traveled in eastward direction. So you assign a value -2 plus 2. But a value 2 meter in both the direction you have traveled. Somebody asks you how much you travel. You can say, sir, I have traveled 2 meter. But when someone asks you in which direction, then you say east and west. Have you got my point? That's why a scalar have no negative value. It may be 0 if you at rest and never travel. So its value becomes 0. So it may be 0, may be positive, but it never be negative. But vector quantity may have negative, may have 0, may be positive because of the direction. Have you got my point? This is the differences between a scalar and vector quantities. Now we have already said what is the meaning of algebraic addition rule and vector addition. We will deal about vector addition rule ahead, but here I give you some glimpse of that. Algebraic addition rule, if you take 2 and 3 and want to add it, so we arrange a number line and we take a unit 2, 1 unit and 2 unit. This is 2 unit, and we have to add a 3 unit after that. So this is 1 unit, 1 unit, 1 unit. This is 3 unit. Now you have to count total. This is 5 unit. So your answer will be 5. 2 plus 3 equal to 5. This is very simple. But in a vector, it is not a simple thing. If I say it is a vector having magnitude 2 in the north direction and a vector having direction 3 in the east direction, then what is the value after adding those vectors? You will be surprised that its value becomes root under 13. So strange, so not. Yes, it's a strange phenomenon, but it is reality. For example, if I give you some example, if football is kicked by 2 Newton, here is a football. A football is kicked by 2 Newton or 2 Newton force or 2 meter per second velocity. You can say anybody 2 Newton force by a boy, and by another player, it is kicked at the same time by 3 Newton. Where the ball will go, in which direction, and with what speed or force it will go? The answer must be given as it will go towards this direction, not this, but this, and it has force root under 13. Have you got my point? I know you